In this video, we'll install a SPIRE identity control plane to our clusters. And for that, I've already downloaded the latest official SPIRE Kubernetes deployment manifests into this folder. So I'll just apply them one by one instead of, typing them from scratch. And I'll display them, talk about them when there is something that needs to be pointed out so that you can see what we are actually deploying. And before we begin, let's create a SPIRE namespace because we want to put everything that's related to SPIRE into this SPIRE namespace. So let's do a kubectl create ns SPIRE. Then I'll create a service account for our SPIRE server to use as an identity, kubectl apply-f server account. Then we'll use a config map for our trust bundles, kubectl apply-f SPIRE bundle config map. And since SPIRE server will need to query certain Kubernetes APIs for node and workload attestation at least, we'll need to create a cluster role and a cluster role binding to allow it, which is done with this server cluster role YAML file. So we have cluster roles, cluster role bindings, roles, and role bindings, just to help SPIRE do its magic and talk to Kubernetes. Let's apply these two by kubectl apply-f server cluster role YAML. Then we'll look into the server config map YAML. And this file and its associated agent config map YAML are typically the files that you'll be touching the most. Here we define a trust domain for our cluster as cluster3 demo. And we attest the node is called cluster3 by using a Kubernetes service account token node attester. And that's pretty much it. And also note that we have a to-do here. We'll modify this part when we start federating trust bundles inside separate Kubernetes clusters, but that's the topic of an upcoming video, so we don't have to worry about it right now. And for the sake of this installation, this file looks good enough. So let's save it and apply it using kubectl apply-f server config map YAML. And in this implementation, our SPIRE server is a stateful set. So let's apply it to using kubectl apply-f server stateful set YAML. We also have a gRPC service for the SPIRE server. So we'll implement it by doing a kubectl apply-f server service YAML. And that completes the server part of the installation. Now it's time to deploy the agent application. For that, we'll start by creating the agent service account that our agent daemon set will be using. It's a typical service account YAML, like you see, nothing fancy. Kubectl apply-f agent account YAML. Then we have a cluster role and cluster role binding for this SPIRE agent as well, similar to what we did in SPIRE server. Let's apply those two by kubectl apply-f cluster role.yaml. We also have an agent config map, which we may want to edit certain parts of it depending on what service account our agent uses or the trust domain of the cluster we are in. For our case, this particular file looks good enough, so I'll just save it and apply it using kubectl apply-f agent config map.yaml. And there is also the agent daemon set that manages the life cycle of the actual agent. There's nothing much to change here, so I'll just apply it as it is, kubectl apply-f agent daemon set.yaml, and that will set up a SPIRE server and a SPIRE agent on our cluster. To verify the setup, we are going to check the SPIRE pods by doing a kubectl get pod-nspire, and I see that we have a SPIRE server pod and a SPIRE agent pod up and running, which is good. I'm going to do an identical setup on the other cluster as well, but since the steps that I follow here will be almost identical, I won't show that part in the video and I'll just implement it behind the scenes. So in the upcoming video, we are going to register our nodes and workloads to SPIRE so that the SPIRE server can verify these workloads, which is known as node and workload attestation in SPIRE lingo. And then it can distribute identities, which are nothing but glorified X509 digital certificates, to these workloads whenever we deploy them to our clusters. So see you in the next video.